Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
Good morning, and you're very welcome to this morning's Signpost webinar. My name is Pat Murphy, Head of Environment Knowledge Transfer with Teagasc. Slurry is one of the key challenges that our farmers face from an environmental perspective. And slurry is implicated in a number of environmental challenges, including losses of nitrogen to water, losses of phosphorus to water, losses of ammonia to air, and loss of methane and nitrous oxide, which are two of the agricultural greenhouse gases. So it is extremely important that we get the management of it right to maximize the agricultural benefit and to minimize those losses to the environment. This morning, I'm delighted to be joined by Noel Meehan. Noel is Programme Manager with the ASSAP Programme. Noel, you're very welcome.
Thanks, Pat. Thank you.
And we're also joined to help with the questions by Eoghan O'Brien. Eoghan is ASSAP Advisor in Wicklow, Wexford, Carlow. Noel, your topic this morning is slurry, maximising agricultural benefit and minimising environmental loss. A key challenge for you and all of the ASSAP advisors and Signpost advisors as well, because it's not just about water quality.
Yeah, I suppose slurry, it's well documented that it's very beneficial resource and source of nutrients on farms, and I suppose this time of the year is probably the main slurry spreading season, and I think it's just timely maybe to talk about the benefits and talk about what it can bring to your farm and how you would do that with maximising and making sure that it's used the best that you can, but at the same time, we just need to be aware that it can have an impact on water quality and obviously on gaseous emissions and also on biodiversity as well. So, that's, I suppose, what kind of prompted the presentation today, that, there was that kind of a lot of people were making phone calls into ASSAP and into the advisors asking about how do we go about this. So look, we have a presentation here that will hopefully help on a few things. Some of it people will know, some of it might be new to them, so we'll take it.
Okay. So when you're ready, if you want to go ahead, I'd remind people that we have the Q&A. So if you want to put questions to Noel, will you please use the Q&A, and we'll ask them after the presentation.
Okay, so look, as I was saying there, slurry is a key resource on farms, and we just need to try and use it as best we can to minimise the impacts. And we've, as I was saying, we've had a lot of contact from farmers and from media outlets and people looking for information around slurry. So look, that's where the idea came for doing this presentation today. So I just want to acknowledge at the outset Eddie Burgess, Mark Plunkett, David Wall, Pat Murphy, Catherine Keena, who helped put the presentation together. So the outline, we're just going to look at the slurry composition and the value of it, optimal use of slurry, how it sits in with the gap regulations, I suppose, just the slurry requirements and why they're there, what we can do to minimise environmental losses, and just finish up with a summary. So this is probably one slide that people have seen quite regularly, but it's just outlining the value or the makeup of 1,000 gallons of slurry. So, and at the different dry matter percentage rates, and the typical dry matter percentage is 6, and that would equate to units per 1,000 gallons of a 9, 5, 32 for NP and K, and if you manage to put that into a bag of fertilizer. So it's quite a rich source of nutrient out there, and to put a value on that then, you're looking at €29 for that 1,000 gallons at 6% dry matter. I've also put in soil water there because soil water is a big source of nutrient as well, and can have quite large volumes of soil water on farms. And the value there for it is 4.75. So again, it has nutrient. It's not just water. It does have a nutrient content, and it needs to be treated as such that there is nutrient in soil water when we use it. and that it needs to be used as carefully as you'd use slurry. And the value for that is €6.80 for 1,000 gallons. But I suppose, maybe to people who say, well, my slurry is thicker or my slurry is thinner. There is a way of doing that, and that's of testing what your dry matter percentage is. And that is using a slurry hydrometer. And there's a picture here on the right-hand side. Now, I've used one of these myself, and they're made of glass, so they're probably not the most user-friendly in the world. But, at the time of agitating, if you could take a sample out and drop it in, it will tell you what the dry matter percentage is on your slurry. And then, based on that, there's tables there, and your advisor can help you with this. You can adjust the rate up or down if you need a certain amount of nitrogen or phosphorus or potassium out on a field. You can adjust that rate depending on the dry matter percentage of it. So you're just maybe recalibrating and making sure that you get the most out of your slurry. So they are there and they can be got, and if you contact your local advisor, they'll be able to tell you where to get one. But they are made of glass and can break quite easily, so just be aware of that. But again, I think it's important that people get a better handle on what their slurry is, because it changes from year to year. Depends how much water needs to come in to help agitate the tank and so on. That might be the problem. So I think that's the first thing that we'd look at. And again, just to reiterate the point that it is quite valuable. €29 1,000 gallons is quite valuable. So then, when and how to maximize your slurry, and again, this may be familiar to people, but we have a range of scenarios here across summer and spring and summer, and across the different application rates. So splash plate, dribble bar, trailing shoe, and injection. And I suppose it's no surprise to the listeners there that we have a range of availability of nitrogen across summer and spring, particularly with the splash plate. You have a 3-unit difference there, 6 units to 3 units if you use it in spring. But I suppose when you look at the technology that's available, you can see that using a trailing shoe in springtime is a 9-unit of in per 1,000 gallons is what you're getting there. So I think the message is that using a splash plate and using it in the summertime, you're losing a lot of your nutrient via volatilization, and that's money that's literally going up into the air on you, and it's obviously ammonia as well, which is a problem gas. So the technology is well tried, well tested, and I suppose it's been rolled out more and more comprehensively by legislation with the cohorts of farmers that are going to be mandatorily required to use it. And it is a 6-unit gain by using slurry in the spring with a trailing shoe versus slurry in the summer off a splash plate. It does help to reduce ammonia loss, so up to 60% reduction as ammonia loss to the atmosphere using less. So that's a quite significant reduction, and it is one of the main pillars of how we reduce our ammonia losses to the atmosphere from the agricultural sector. And I suppose the other win out of this is because you're utilizing more of the nitrogen fraction, you get more value of your slurry, and then the knock-on effect is that if you have more nitrogen from the slurry, you should be able to lower your chemical in requirements on the back of that. There's a lot on this slide, but I think it's just to try and highlight the fact that when you're spreading your slurry, that you need to be aware of how you maximize it and matching applications to grass in demand. And I suppose just on the left-hand side, if we look here, we have the typical grass growth curve for 2020, 21, 22, 23, and the 5-year average. As you can see, that it's pretty much, it doesn't change a whole lot, across the years. So the range is very tight on there, and you can quite clearly see on the graphic that it's really towards the latter half of March that we really get the surge in growth. So I suppose, what does that mean? If we look at January week 3, so that would be when the close period has ended and people are starting to go out, and you look at maybe around 15,000 gallons per acre of a slurry application, which would deliver 17 kilograms per hectare of in application rate. How long will that? With the growth rates that are there, and they're quite low, they're only in the early mid fives, six, sevens, that kind of thing. It will take up until the end of February for that, give or take, that 17 kilograms of nitrogen from the 1,500 gallons to be utilised up. And that's a quite important point to make, because if you have a higher application going out 2,500, 2,000, 2,500, 3,000, you have a lot of nutrient coming out there with a very low growth rate, and the potential for that to be lost is quite high. So I think the message that we're trying to get across here is that you need to match your application rate to your application of slurry to the growth rate, and where you have to go out in late January, early February period, that you need to be putting out a lower volume or lower rate of slurry, just to make sure that you give it the best chance to be utilized up. And then, when you come out later in the year, in towards into March or early April, when the growth rates really kick off, as you can see, here the growth rates are really kicking off. That's when you can go with your heavier applications, and that's when you get the most utilization of it. So I think that the message out of this is just be aware that the growth rates are quite low. If you do have to go in this time of the year, that you put a light application, and then once the growth rate hits off, you can go with your heavier application. So I just for a minute going to talk about a little bit of research that came in from the ACP, and it's comparing organic P versus chemical P. And how and its susceptibility to loss via water, and it's just a bit of research from Teagasc Agricultural Catchments Programme. We had 5 treatments: chemical P, cattle slurry, pig slurry, hen manure, and a control which got no fertilizer, and it was on 4 different types of soil, and it was analysed for Morgan's P and for extractable P, water extractable P. So that's, I suppose, mobile P or plant available P. And it was an analysis of 70 days, and with different responses across different organic manures were recorded. And I suppose the riskiness and uptake depends on the soil type and the soil P level before application. So I'll just get into a little bit of detail on that now with Chi. So what we have here is 4 soils with a low initial soil P test to Morgan's P test. Soil A, B, C, and D, and you have your starting point, control, chemical, and so on down across. And what we're saying here, in general, organic manures will raise the soil P by the same or more as chemical P. So what we're saying here is that on low indice soils and on high indice soils, that by applying your chemical or your organic manures across different manures, it will have as a positive impact on raising the P level as chemical. So it's as effective as chemical P in providing the growing crop with phosphorus. And this one we're looking at the water extractable P, and it's the same set of soils and same treatments. And what we're finding here is that soils that receive chemical P have a higher risk of P loss than organic P in both low and high scenarios. So what we're looking at here is that the chemical P, the risk of loss of chemical P across the different soil types is slightly higher than it is from the cattle, pig, and poultry manure. So what we're saying here is the conclusions that organic manures are as good as chemical P and probably safer, provided they are applied at the right time and place, etc. So, organic fertilizer, they're really, really, really effective at providing phosphorus. They're safer, but they're only safer and only provide that if they're used at the right time in the right place and used very, very carefully. The issue, I suppose, is that for various reasons, the organic fertilizer may not be used optimally, and that's when you have the problems with it. And look at maybe, I suppose, just my own kind of thoughts on this is the chemical P, because you're going and actually buying that there's a higher value put on it by the farmer, him or herself, that they're much more careful with how they use it as opposed to how they use slurry. But look at it, I think that's just a nice insight into how important a source of nutrient and how effective it is at providing P. Slurry is at providing P, and that it is a safe source of P, provided that it is used in the right circumstances. The gap regulations, I suppose, I get the sense that the gap regulations are seen as just something that farmers have to comply with, and you know, there's paperwork and there's bureaucracy, and they're a nuisance really. And I think that unfortunately loses sight as to why the GAP regulations are there. They're primarily, first and foremost, there to protect water. That's their that's their function, is to protect water. And I just picked out a couple of the keys, you know, regulations around slurry storage. So that are around slurry, and that's the storage, the closed periods, and the soil water storage. And I suppose, why are they there? What's the reason behind this? And you know, I've spent many a day, many an hour, you know, talking to farmers about the closed period, and what farmers feel is the injustice of it, and that, you know, the weather is very dry could be very dry, and the ground conditions are perfect for putting out slurry, and why can't we go? And you come to this time of the year and you have maybe less favorable ground conditions and more risky, more of a better chance of going out with rain and so on. But I suppose the Agriculture Catchment Programme, this is a paper that was done by Maria Shore, have looked into this and looked into it very carefully across 4 different catchments, 2 grassland catchments, 3 grassland catchments, and an arable catchment. And across the 4 catchments, you can see that they looked at the closed periods and looked at it across 2011, 12, 2013, 2014, and recorded the total phosphorus that left the catchment during the closed periods. And what you can see is that in the closed periods, that there's a higher, more spikes that happen during the closed period of phosphorus leaving the catchments. You have an exception here in 2011, 2012, where you had a very wet 2011, 2012, and that drove up during the summer months. But typically during the closed period, you have the highest level of phosphorus loss. So that's during the closed period when farmers weren't putting out slurry on the ground. So if you had added an additional loading of slurry onto that ground during the closed period, you'd have probably an additional level of phosphorus being lost. So the idea, or the conclusion, is that a disproportionately high nutrient loss occurs during the closed period. 43% of total phosphorus loss occurs during this period, and they also looked at nitrogen. Although the graphs aren't there, but they also looked at nitrogen, and it was around 45% of in-loss occurs in that period of the closed period, so in 25% of the year. Why does that happen? I suppose, you know, it makes the reasons is that, you know, you have a higher chance of the soils being saturated, you have lower growth rates, so you're going to have phosphorus and nutrients, nitrogen sitting on the soils, not being used by the plant, and obviously we get a higher risk of heavy rainfall events during that period, more overland flow, more leaching of water moving through the water table, and that's going to move your nutrients. So if you have an additional loading of organic fertilizer on top of that in that period, you're only going to exacerbate the problem. So that's the reasons why the closed period is there, and it is very important that we adhere to it and make sure that we don't add to the problem that's there, because this is going to happen anyway. So we need to minimize the load and take actions to prevent it from happening. The other one I'm going to look at is around the buffer margins, and then, you know, the one it's like nearly saying your prayers: don't spread on frozen, snow-covered, waterlogged, flooded, or likely to flood. Heavy rain forecasted in 48 hours, and it's kind of rhymed off like that, and nobody kind of takes any heed of it at all. But they're very important. This is a photograph that a colleague in ASSAP took, where you had a farmer that went to spread slurries on the 25th of January. So I suppose, you know, the first thing, buffer margins in that stage, it should be a 10-meter buffer margin. Out from there, there's a river going along here, it should be 10 meters, and it goes back to 5 as we move along into the season. Now it's not waterlogged or snow covered, and it's not flooded, but it is likely to flood because it's beside a river. And I don't know when the heavy rain was forecast, but on the 12th of February, this is the same field. So, you know, clearly that field was at risk of flooding, and the buffer margin wasn't adhered to. It was, you know, it was what we would call in ASSAP a critical source area, and is a field that needs to be avoided from having slurry spread on at certain times of the year. And the rules or the regulations are there. They're there for that reason, to protect those kind of areas. And they're not just there for fun. So I think it's important just to highlight that when we have these requirements in the GAP regulations, that they should be acknowledged as a protective measure for water quality and need to be adhered to. So I would say, and this is just an opinion of mine, it's the minimum, the requirement is to have your 16 or 18 weeks or whatever it is. But I'm talking to farmers out there, and those that have excess slurry storage over the 16 or 18 weeks or 20 weeks, whatever it is, it allows them to make better decisions on when and where to use their slurry. And look at it, I fully acknowledge that a lot of people are just about able to have the minimum and the cost of it and all the rest. But where you do have that additional slurry storage, it gives you much more control. And the quote that I got off a farmer was that the stress levels on him reduced quite significantly because he wasn't looking at the tanks being full and knowing that the ground conditions were bad and having to go out and put it out in risky scenarios or risky conditions. So look at that's just a thought of mine that where we have have excess slurry storage, it can be quite beneficial, and it will certainly help you utilize that slurry much better and much more effectively. I'm just going to talk about the PIP maps. I'm not so sure if our listeners are fully aware of them, but I think the PIP maps are now available on NMP Online. They're also available on the catchments.ie website, and the EPA are hosting them, and they're an excellent resource. And I think what I'm trying to do here this morning is maybe make our listeners aware, and particularly the advisors that are on the call, aware that these are now available to you, and that you should try and access them to help inform your decisions and your advice that you're given to farmers in relation to how you use slurry and how you use your nutrient, I suppose, and areas of the farm that are risky, and adopting your advice to the farmers on the back of that. I will say that these are an excellent resource. They are a guide. They are a guide and do need to be ground truthed. And what I mean by that is you do need to go down the field and make sure that they line up with what's going on the ground. But by and large, they're quite accurate and they're very, very useful. So there may be little bits of anomalies here and there, but not too many. So just from the PIP maps point of view, you can see the different colors, but you have a different ranking of PIP. So the pollution impact potential for nitrogen, you have the purpley colors. So rank 1 is the highest risk for in-loss, and rank 7 is the lowest risk for in-loss. So on this farm here, you can see, this northern half of the farm, the far side of the road and around the farmyard, is all PIP rank 1 and 2. So very high risk for phosphorus or for nitrogen loss. Whereas on this part of the farm here, it's very low rank. It's a rank 6 for nitrogen loss. So obviously there's something going on there. You can take that information and say, I wonder what's the reason behind that? And that's just the aerial photography of it. So you can see it's a dairy farm. It's quite well laid out. But this lower part here, alongside the river, that's the river there, is PIP rank 6 or 7. So we look at the phosphorus one, and the phosphorus one is on the same scale, a rank of 1 to 7, with the darker colors being the highest risk and the lighter colors being the lowest risk. And we can see that it's the complete opposite to the nitrogen one. So the nitrogen one is all up here, and you can notice the curve there. Here you have the phosphorus is all high risk alongside the riverbank, and up here is low risk, and that's just reflective of the soil type. So obviously, this is very free draining soil. That's why your nitrogen is your risk. This is much heavier, poor draining soil. That's why your phosphorus is a risk. You can also see here this hatched area, and that's the soil organic matter layer. So that layer is on NP Online as well. So that overlays nicely with the PIP maps. And again, it's just giving you a little bit more information around what's going on the farm and how you might change or tweak your advice based on the back of that. And we'll just throw these two maps as well into you. These are the overland flow and delivery point maps. So as you can see, these kind of squiggly areas along here That's where water starts to move over land. They're tied in. If you recall, these are the PIP P areas, so the high risk for phosphorus areas, and they tie in usually where you find these overland flows. So again, it's a function of the water not being able to get down through the soil. It's impermeable and starts to move over the land, and you have delivery points in along the curvature of the river. So again, these will provide more information for the advisor and for the farmer as to how to make decisions around what they should do with their slurry and their nutrient at certain times of the year. That's the organic matter layers. I spoke about that already. And I suppose where we've gotten to now is we have the PIP maps on in and line. So we can now use the PIP maps and in conjunction with our soil maps, so our soil fertility maps, to help make better decisions. So you can see on these that you have a phosphorus issue, you have a pH issue, and you have a K issue on the northern part of the farm. So that's all high risk for in loss. And I suppose where the temptation is that you would compensate for poor soil fertility with increased nitrogen loading to compensate for that. But where you don't have the proper pH, the proper P, and the K, you're not going to be you're not at optimum soil fertility. So you have a greater risk of excess nitrogen being applied to make up for that, and you have a greater chance of nitrogen leaching. So I suppose what we're coming at is now with the PIP maps, we know it's risky for in-loss. We also know from the soil fertility maps that it is not at optimum soil fertility. The advice needs to be changed, or needs to be put to the farmer that it's your soil fertility that you need to fix first before you go adding additional nitrogen on it, and therefore you're reducing your nitrogen at risk of being leached down through the soil profile. Likewise, down here in the southern part of the farm, where you have those overland flow pathways and your heavier soils, that photograph I showed a few minutes ago, really you shouldn't be going anywhere near this with slurry anywhere at all until later in the season when the weather dries up that little bit. So you'd be advising the farmer to avoid this area down here with your slurry applications, because it is at higher risk of nutrient or at overland flow and nutrients being washed into the river. Those PIP maps are available on InNP Online, and they're also available at catchments.ie or that web link there. So how can we maximize slurry use? The importance of nutrient use efficiencies. We need to reduction in nitrogen use and nitrate losses. That's what we need to do. So the right time, soil temperatures, 5-6 degrees and rising. Soil moisture deficit. So this is what we spoke about. Is the soil at saturation point, or is it close to saturation point? And then obviously with the converse, where you're at drought, is there rainfall forecast, and what's the growth rates like? And I suppose we all live in the real world a little bit, or I hope we do. And other factors influence these. So have you sufficient slurry storage? Are you able to hold on until you get the temperature is a little bit better, the soil moisture deficit a bit better, the growth rates are a bit better? The contractor availability is a big problem. The contractor will come and say, yeah, I can go and do that for you tomorrow, and that's it. You have to take them or leave them, and if you leave them, you mightn't have them back for a fortnight or 3 weeks, and you could be in big bother. So obviously the contractor plays a big part in this, and then obviously the farm workload as well. We're in the middle of calving period at this stage, and farmers don't have time to be maybe worrying about slurry, and they just want to get it out and get that job done. So look, I suppose what I'm trying to say is insofar as we can as farmers and advisors, that we try and tick as many of these boxes as we can before we go and put the slurry out. But notwithstanding the realities of the work pressure and the circumstances farmers find themselves in. And the reason why we're looking at the right time is, again, this is just a similar slide I had earlier on. The growth rates, in the early part of the year just aren't there. It's really around Paddy's Day that we get to the point where the growth rates start to take off, and that slurry is being utilised most effectively. The right locations. So we're looking at our dryer fields, watching out for critical source areas, like I showed there on the PIP maps, PK and pH. So you want your soil fertility optimal. I suppose the use of umbilical and low pressure tires. and they're becoming much more prevalent and much more popular. And I suppose while they're a great advancement in technology from the point of view of application rates and getting slurry out quite fast and covering a lot of ground, I saw a quote from a contractor in one of the media outlets that saying how great it was that the umbilical systems were there, because it meant that they could get on ground that was that bit wetter and get the slurry out. And I suppose from a contractor point of view, he's absolutely right. But I suppose I was just in my own head saying, if the ground is wet like that, if it's close to saturation and you're putting 1,000, 2,000, 3,000 gallons of slurry out on that, and you get heavy rainfall, you have a very high risk of that slurry being lost. So while the umbilical is very good and is a positive technological development, we just need to be aware that wet fields are wet fields and are highly risky for nutrient loss. And if we're advising or talking to a farmer as advisors, or if there's any farmers on today, you just need to be aware that the wetter the soil, the more likely, and if you get heavy rainfall, the more likely is that slurry is going to be lost. So, just be aware of that. The right rate, so we spoke about matching the application rate to crop demand and growth rate, and then obviously early and late application of slurry. So, very early on, as I showed you on a number of slides back, the growth rates aren't really there. So you just need to make sure you have a lighter or lower application rate. And then obviously towards the end of the year, again, the growth rates are dropping, and we need to be aware of that. And finally, just making sure that we use as much of the low emission spreading techniques that we have, the dribble bar, the trailing shoe, or the injection, to maximize our utilization of in. So just on biodiversity, I suppose it's important to acknowledge that slurry has a role to play in biodiversity from a negative point of view. And having spoken with Catherine Keena on this, her take on it was that farmers need to just identify is there fields that they want to keep biodiverse rich, or field boundaries that they want to keep biodiverse rich. And if there are, there might be in acres, and that will highlight them for them. Well, if they are, you just need to avoid nutrient applications on these fields, because what happens is the nutrient promotes competitive species versus the wildflowers. They outcompete them, and they take over, and the plants suffer as a result. Really, what you're looking for biodiverse pastures is nutrient poor soils. So really no application of nutrient really is what you're looking at. So slurry certainly wouldn't be beneficial from that point of view. The damage can be irreversible. If we have an old pasture there and it starts being farmed more intensively, you will do serious damage. The other key area on farms is your field boundaries, and that's why we have the buffers there to protect those margins. Be it your watercourse margin, but also, as you can see in the photo behind there, you have a lovely field margin there where no nutrients are getting in, and it's just being let grow. And that's the photo from Noel Meehan down the Bride project, and it looks fantastic down along by the ditch there. So it's no reason why we can't have more of these along our hedgerows and our walls, but it just means that we need to make sure we don't have any nutrient going in there. Okay, to summarize, slurry is a valuable source of nutrients on a farm, but we need to optimize how they use slurry to utilize effectively. So we've gone through a lot of scenarios there, a lot of information around how to use them effectively, but it's too valuable of a source, and it's too impactful on an environment not to be doing this. And while every farmer tries to do their best with it, we just need to maybe have a little bit more awareness of the potential pitfalls that are out there, and take actions to avoid them. We have a range of new maps and tools to assist advisors and farmers to make better decisions. And I encourage people to start using those. And look at, I suppose, that maybe a little bit of a request. It is urgent. We do need a wider adoption of environmentally friendly slurry use practices minimize impacts across water, across greenhouse gas, across biodiversity areas. All those areas are under threat and under pressure in Ireland, and we need a more wider uptake across the whole of the farming sector to try and reverse these problems that we have. So, Pat, that's my lot.
Thank you very much for that. You might stop sharing there. Okay.
Yeah.
Just a reminder people to put their questions into the Q&A. Just, I suppose, Noel, you talked about the biodiversity issue, and I think one thing that's going to change the requirement there for a good few farmers is the move towards results-based from I suppose an action-based, where they were allowed in previous schemes to put out a certain amount of organic nutrient on some of the more highly biodiverse pastures. But now that we're at results-based, the reality will be, I suppose, that you're going to find it very difficult to keep those species if you do apply that nutrient.
Yeah, and look at, I suppose Catherine Keane would be the biodiversity and acre specialist, but look at, if you add nutrient, you're given competitor species, less desirable species, a boost of nutrient, and they will pretty much outcompete what's there. So like I think it's very clear, it's one is counterproductive to the other, and like I was on a webinar yesterday about CAP, and about how it can be a little bit the CAP maybe isn't doing what it could. It's more production orientated and so on, and that the results-based system that we have in Ireland was brought up at it. This is at a European level, and it was brought up at it, and how it's key to disentangling the production from the results to get environmental outcomes. So we're fortunate that we're ahead of the game, really, I think, on that in Ireland. But again, it's important that other areas of the farm, maybe there's farms that aren't in acres, that we try and just make people aware that going out and adding a nutrient to it, it will have an impact. It will have a negative impact on biodiversity and wildflowers and so on. But look, that's for farmers to decide what they want to do ultimately. But from a biodiversity point of view, you'd be encouraging to avoid those areas and maybe concentrate on other areas of the farm that could improve the productivity on.
Okay. Yeah. There's a question of two halves here. What advice is available to farmers about the pros and cons of spreading slurry on saturated land following a wet winter and a high winter table? I suspect it won't take you long to answer the pros on that anyway, whatever about the cons.
Yeah, look, I think we just need to raise awareness around all this. We have more information now for farmers. We know on farms where the fields are that are susceptible to being saturated and to high water table, and we need to ask farmers or make them aware to avoid those. And the thing about it is where it might be trafficable now, it may not be trafficable in 2 weeks' time or 3 weeks' time, because the weather can change, as we know, in this country. And the photograph I showed a while ago can do that. Like, in the January, the field was perfect for spreading slurry. It probably was quite dry. The soil moisture deficit was fine. But 2 weeks later, the field was flooded. So I think what we need to do now is use the maps that we have and give direction to farmers to say, listen, in this part of your farm here, this is susceptible to runoff. It's susceptible to flooding. You have another part of the farm over here that is drier, less connected to the drainage network, less risky. It's really there that you need to go with your slurry if you have to go out with it. But ultimately, you're trying to advise the farmer to hold as long as he can until he gets the most favourable conditions possible. I know that's not always the case, because slurry storage is a problem on farms. Even if you have the 16 weeks or the 18 weeks, this year was a very early winter. You're probably in maybe 2 or 3 weeks earlier than normal, which means you have to go to your full 2 or 3 weeks earlier than normal. So you have all those practical concerns and practical issues. But We do need to try and up our advice and up our understanding to the farmers around what parts of your farm are susceptible or at risk for slurry loss or nutrient loss, overland flow. And we have the information now. So that's what we're trying to get across this morning is those maps are there, and we need to start looking at them and using them and providing advice in the back of them.
Yeah, and I think one of the things that you're saying is slurry storage is and is going to be in the future absolutely crucial to a farmer's ability to manage their slurry effectively.
Yeah, and you look at climate is beginning to bite. You can certainly see that you have more heavier, longer, wetter periods. It was wet since the 1st of July until I don't have the dry sense. We had a couple of dry spells, but you had a very wet.
Allegedly a drought in Moore Park in January.
Okay, well,
technically,
but what I'm getting at, like the weather is changing, and that's impacting on ability for farmers to get slurry out in these fields. So we need to start, really looking at how do we future proof a little bit around climate change as well. I spoke to a colleague that has a slatted shed on a bit of a hill, and for the first time since the shed was built maybe 20 years ago, water came in over the Christmas period into the tanks because of the level of rainfall that had been happening. It never happened before in the 20 years the shed was up. So those are the warning signs that we have there, and there's probably multiple of those around the country. So we just need to start thinking long term on this and forward looking at what the risks are coming down the line from climate change, and then using the information that we have to try and make better decisions around how we utilize our slurry and our nutrients.
Eoghan, a lot of questions coming in.
Yeah, I'm just taking notes on a few of them there. I suppose I'll start off with a few of the easier ones for you all. How does using trail and shoe help water quality?
Well, I suppose the trail and shoe really is for ammonia. It's to reduce the gas that the ammonia emissions. From a water quality point of view, trail and shoe is slurry. You still need to use it in the fashion I described already. You need to watch where your soils are saturated, where they're likely to flood. You need to keep your buffer margins. So per se, the trail and shoe has very minimal benefits for water quality, but it's slurry, whether it goes out in a splash plate or a trail and shoe. You just need to treat it as a nutrient that can be, or as phosphorus and nitrogen, it can be leached or can be washed over land flow into a stream. It's all about using it in the right conditions, regardless of whether it's a dribble bar or a splash plate. Splash plate obviously isn't as good for ammonia emissions, whereas the dribble bars are.
Yeah. Another one in there, I suppose, given the weather that we're having, advice to farmers with saturated land and full tanks.
Yeah. I guess the advice is, you try and find your driest, least connected field, and you relieve the pressure. Get out a couple of loads that maybe gives you a week or a fortnight, and you'd hope that maybe that the ground conditions will be better in a week or fortnight's time. Other than that, you're looking at sourcing another tank and moving it somewhere else, something like that. And it's very hard to give advice out knowing the full circumstances of this, the scenario that the question is about. But that's kind of what you're talking about in the short term anyway.
Yeah. And hopefully the weather will take up in a week or two.
Hopefully the weather will take up, and look at it. It is. I mean, as I said, maybe we're not living the real world, but what I'm trying to say is we need to just be aware of the pitfalls, where they are, and try and adhere to obviously the regulations, but make sure that whatever we do, whatever actions we take, have the least amount of impact on water quality or biodiversity or whatever it is. And we have a lot more information out there now to help farmers with that. And in that scenario, it's really relieve the pressure, get to your driest fields, put it out for as light as you can, and then
I suppose keep watching the tank for when the weather does take.
We'll be out of March then, so there'll be much more evapotranspiration and much more daylight, and you'll be hoping things will be drying up a bit.
Just another question in there on the pit maps. How are they actually created?
The pit maps, is it?
Yeah.
Yeah. Right. So the PIP maps are generated from a lot of different areas of information, and they were created by the EPA. I suppose that's the first thing I need to say. So the EPA will be able to give the more definitive answer on it. But my understanding of where they've come from is they have taken all the available information from the soils maps that are the soils information that's out there, the subsoils, the bedrock maps that are out there. So we have a lot of information from the Geological Survey of Ireland that has mapped the whole country and across those areas. And they also include lipis data, so cropping history and stocking rates are also included in them. So when they put all that together into their model, that's what generates the maps. And as I said before, they are very instructive. Particularly the phosphorus ones, I find that the overland flow pathways are quite accurate, but they do need to be ground truths. You could have farmer may have dug a drain or something across a critical or an overland flow pathway, which would mean that that's not reflective on the maps. The other thing I'd say about them is that the EPA are looking to update them. The stocking rate and lipis data that they are based on is, I think it's 2017 or 2018, so it's a little bit out of date, and they're in the process of updating the data with more recent lipis information. So, times change and things change and land use changes, and so that will change the PIP rankings as well going forward. But that's where my understanding of where they have come from on.
Yep, and just another question in there: can farmers view these maps themselves?
Yeah, absolutely. They are on catchments.ie website. We could do a demo here, but we'd have the rest of the webinar used up. But they're there on catchments.ie. If you go into the map tab on catchments.ie, they're all there now. That map or that system has a massive amount of information. It has a whole load of water quality information as well. And for the listeners that are on the call there, it'd be well worth going in and having a look. It'll take a bit of time for you to find your way around it without maybe somebody demonstrating it with you. But they do have videos, I think, as well, in fairness to them, that show you where to get information, help videos in it as well. So look, if you're going into it, give yourself a bit of time. It's not a 5-minute view. It's probably an hour or 2 hours view to get your head around where all this stuff is. But it is very, 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 very useful and full of information. So somebody can if you have time to go on it, I'd advise you to go on it,
And it's phenomenal the amount of detail. If a farmer does go in on it, you could spend hours looking at it and you'd see things from years ago that were on your farm, and you realise humps and hollows and what way the water does actually move.
Yeah.
An interesting question in there: how much slurry storage should we as farmers aim to have?
Well, I think you should have the minimum requirement, which is 16 weeks or 18 weeks or 20 weeks, and there is anecdotal evidence out there that farmers don't have that in some circumstances. I think in fairness, most farmers aren't too badly fixed with regards to that. I think you need to look at your own circumstance. Why does a regulation there? It's a one-size-fits-all regulation. So it's 16 weeks in the southern half of the country, 18 in the middle of the country, and 2022 up the north part of the country. I think the best person to answer how many weeks storage I need is the actual farmer themselves, because they know their system. They know when they have to go in and house. They know when they typically can get out and spread slurry. And if you feel that you're not able to, that you're putting slurry out in less than favourable conditions every year, well then, but you have the minimum requirement, well then maybe you do need to have additional slurry storage. And the example I gave of the farmer that put in additional slurry storage, he had the 16 weeks, but he felt this time of the year that he was under pressure with cabin, the ground conditions weren't just ideal, and he was just stressing himself out constantly around what do we do with the slurry. He went and put in an additional 4 weeks, and he said that the weight that lifted off his shoulders was unbelievable, that he didn't have that stress and that he was in more control and was better able to use the slurry in a way that he wanted to. So I think the best person to answer that once you have the minimum is the farmer themselves, how much additional they want.
Yep. So have the minimum, but decide yourself then after that.
Yeah.
Perfect. Question in there for someone in acres. If they have a traditional hay meadow and they want to go with some slurry on it, I suppose, will it have a negative effect is the question.
I suppose Catherine might be the better one to answer this, but look, I think the principle that we outlined is, when you add nutrient to a crop, Catherine's philosophy would be, to avoid putting nutrient on these biodiverse rich areas that you're trying to protect. So I suppose, I know in acres you're allowed, or I think you are, and traditionally hay meadow you were in glass anyway. So I suppose, look, you need to see on that one. I think the person to go to is your acres advisor. I'm afraid I'm not up to speed enough in acres to give a definitive answer on that.
Perfect.
No, there's a few questions in there, and fairly controversially, and basically asking the question, if we went to an all arable agricultural system and got rid of our animals, would that have a positive impact on water quality?
Yeah, that's a fair shift in policy there, but
the reality
the answer is that it would have problems as well in all arable, because the tillage areas are typically in the free draining areas, and we know from work in the Slaney and the Barrow that nitrogen is a big problem there. And we also know that, like, it's coming across from all the enterprises in the Slaney and the Barrow. So there's your grassland and your tillage. But tillage, you need to have your cover and catch crops in to mop up nitrogen to prevent nitrate leaching. You need to have your in the winter period or the autumn period. If you have bare soil and you get heavy rainfall, and Wexford and Carlow got plenty of heavy rainfall this autumn, and you start to get soil moving. So if you have loose soil, you're going to have soil moving with water and getting into the drainage network. You've often seen the Slaney and tributaries of the Slaney with little brown colour on it. That's soil getting in from tillage fields.
And I think the other side of it is if we shifted on our heavier lands into tillage, we'd have massive problems with soil loss, with soil degradation, and with phosphorus and sediment into the rivers. So I think really it's a very simplistic view to think that a shift to tillage would do anything. I think it quite the converse. I think our grassland agriculture is probably heavily protecting our water quality.
I think so, and there's a bit of research from the catchments program where a farmer did a reseed. So a reseed is where putting grass back into it, but there was a massive spike in nitrate from that reseed. It was only in a couple of acre fields, and there was a massive spike. If we went and ploughed up all the permanent pastures or a lot of the pastures that are around there, you're going to have a massive spike in nitrate from that release, because there's a lot of nitrate in the organic matter in the soils that is existing there, and reseeding or ploughing up releases that. So I think the unintended consequences is what we need to watch out for, with things like that.
A question: Do Maca swivel spouts qualify as less?
I'm not familiar with
No, I don't think they are.
But I don't know.
So just there's a couple of questions early on in relation to some of the number of products, and it's that will reduce methane in slurry, and there's a number of technologies I think coming down the line that are showing significant potential in that space. It's something we will go into, I think, in a later
Yeah, I look at it, I kind of avoided it, to be honest, because I wouldn't be an expert in that, but I know, Dominica Crowell, I think is the person who does a lot of that in Johnstown Castle. So, maybe it's one for another day that we specifically around slurry additives and their benefits might be a topic for the webinar at some stage.
Yeah, and there's a question there. Again, it's probably one that we're not overly familiar with about any thoughts on slurry separation for nutrient management. But again, I think it's one that it's difficult enough to see how it's going to improve things massively, because you still end up with okay, you're removing solids, the majority of your liquids are going to contain your nitrogen, and a lot of the solids will go in with phosphorus. But I still don't see, you're going to have 90% liquid still there, which has to be spread. I don't think it's much of a solution for anybody.
Yeah, look, a nutrient is nutrient, whatever form it is in, and you need to use that nutrient at the most beneficial time from an agronomic point of view and from an environmental point of view. So, in theory, dry solid fraction of slurry is probably more stable. But if it's put out in the wrong conditions, it can still impact, so.
Question in there, should there be more training around slurry use and slurry application?
Yeah, look, I suppose there isn't any specific training per se that's out there, but I think what we could really benefit from is just maybe a reset on the whole thing. Like the regulations have grown so much in the last 4 or 5 years in particular, with all the additional measures that have been added on. And I'd like to bring us back to the basics. And the basics are having your slurry storage, your minimum slurry storage, and having it fit for purpose. And then when you are using your slurry, that you adhere to the buffer margins, and that you adhere to the rainfall forecast. I think people just ignore the rainfall forecast. Like 48 hours is what they say, but really, I'm not so sure that's 48 hours. Will do the job. And all those things. So we need to get back to the basics and start looking at those. And maybe it's a reset we need on there around that we remind people, because I think there's so much being thrown at them that they've forgotten, or maybe not forgotten, but maybe not given as much store to the basics around buffer margins and spreading times and slurry storage that should be there. So I think there's room for improvement definitely on it, but I don't know is mandatory training or that the answer. I think it's more is an awareness and getting back to the basics.
Yep.
Okay, I think we're hitting our time limit there. I would like to say thanks very much to Noel. Hugely important issue. I think we've to resolve a lot of our environmental issues in agriculture. Slurry is going to be one of the key elements to doing that. So thank you very much for your presentation. Eoghan, thanks very much for the questions. Just a reminder that next week we're dealing with what is again a really important topic. We saw earlier in the year that the HSA had a campaign around health and safety, particularly in relation to the calving period, and conducted a lot of visits. So next week we've John McNamara and Francis Bly looking at managing health and safety on the farm in the busy spring period. So really an important topic. I would look forward to that. And just, I suppose, a final reminder that Teagasc are running the Farm Sustainability Awards, for which entries will be accepted up to the end of February. So if there are farms out there that are going above and beyond in terms of I suppose, producing food and producing it very sustainably, there's an opportunity for a significant prize fund to be accessed there for those farms, and for, I suppose, most importantly, the lessons that have been learned by those farmers to be spread to others. So the details of the application for that are on the Teagasc website. So until next week, Thanks again to our speakers. Thanks to Eoghan for all our work behind the scenes. And hopefully we'll see you again next Friday.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.